People are not lions, and people are not horses either. So I was in the Game Changers and corresponded significantly with the directors and producers. And, overall it was very good. Documentaries, though, are about making a point. And when you're making a point, particularly when you're trying to rectify a misperception, and in the case of the Game Changers, the misperception is if you want to be a badass, you've got to eat meat. If you want to be big and strong, you've got to eat meat. If you want to be a supreme athlete, you have to be omnivorous. That's false. You can fuel the supremes of human performance on a plant-exclusive diet. So I think the movie made that point very effectively. But when you're making a point, sometimes there is a tendency to tell just part of a full story because that part better makes your point. So, any of you see it? Game Changers? So, there's this segment in the middle where they're talking about anatomy and they compare the human anatomy to a lion and the lion's GI tract is shorter and all of that. And okay, we're not lions. That's true. Lions are obligate carnivores, we are not. What they didn't do was continue the comparison and say, okay, here's an obligate herbivore, like a horse, and we're not that either. I have a horse. My horse horses colic periodically. They have very vulnerable GI tracts. My horse did some years ago. Wound up having surgery, and they extracted 15 feet of his intestine. And I was warned by lots of people in the horsey world that he would never recover fully. He did. They just need to be given the opportunity. He's perfect. But that's my point. He lost 15 feet of intestine, and neither of us can tell. That doesn't tend to happen with people. You lose 15 feet of your intestine, it makes a hell of a big difference. So we're not horses either. We're in the middle. We are clearly anatomically, physiologically omnivores, and I don't think anybody should be reluctant or ashamed. You know what that means? It means we've got choices. And then it's up to us to make good choices. And as we've been discussing extensively, the good reasons to choose plant-based diets include not just our own health, but kinder, gentler treatment of our fellow creatures and good stewardship of the planet. Make good choices.
Okay, Alex, I want to present the alternative view on that. There are profound differences between, of course, strict carnivores like lions and the type of herbivores that horses are and the type that humans are. But the remarkable thing is that if you look at the human GI tract and compare it to that of a horse, they look remarkably similar. And what's really interesting and really important is to understand that animals that are designed to subsist on a diet of other animals have to have a specific suite of anatomical adaptations that make that possible. Number one, hunting is inherently inefficient. Even the best designed predators on the planet will only make a kill in the wild on an average of 7 to 10 days. That means a study that was done in the Isle of National Royale National Park in Canada showed that one of the largest wolf packs were unsuccessful 95% of the time they went out to hunt. That meant that 95% of the time they tried to get a meal, they didn't get it. So the question is, what in God's name could allow an animal to miss 95% of its meals and still survive as a species? How can these predators eat once every 7 to 10 days and still not only live, but have enough energy to reproduce and raise their kids and then, make it till they can have another meal? Well, one of the biggest things is that they have giant stomachs. They have stomachs that allow them to eat 30% of their body weight at a single meal. That would mean that a person who weighs 150 pounds could eat 45 pounds of food at a single meal. Nobody can do that. The fact is that from elephants down through rabbits, all herbivores actually eat about 3.3% of their body weight every day. That actually includes humans. If you weigh the amount of food a human eats over the course of the day, it will come out to be roughly 3.3% of the body weight, depending on whether or not they're overeating and blowing up to the size of a Michelin man. So but this is important because it has implications for not only our physiology, but also, and this is where we've really dropped the ball, on the kind of research we should be doing in trying to understand human disease. We're told that we're omnivores. Everybody's been told that. That's a lie, because the true omnivores in nature not only have anatomical adaptations to both procure and consume animal food and plant foods, they also have physiologic adaptations. So, for instance, you look at a bear. A bear can literally not eat for 6 months, come out of the den, find a rotting deer carcass, eat, 30% of its body weight of that a deer carcass, and be perfectly fine. Do you know what happened to concentration camp victims when these camps were liberated by Allied soldiers and these starving people were given food? Many of them died because when they were given this massive concentrated load of very osmotically active food, it caused a massive shift of fluid from their already depleted bodies into their digestive tract. They got diarrhea, went into circulatory collapse, and died. That's why when you go into the hospital, if you have bowel surgery and you stop eating, the surgeons insist that you start to refeed yourself in a stepwise fashion, because herbivores have a trophic digestive tract, meaning your gut cells only mature if they're constantly exposed to food. If you stop eating, they stop maturing. If they stop maturing, they lose the ability to hold water and prevent water from translocating from your circulatory system into your digestive tract. They lose their ability to do that whole absorptive thing that they do, and I'm kind of sort of shortening it. It's a little more complicated than that. But the differences between carnivores and herbivores actually even comes down to a subcellular level. And what I mean by that, there is a suite of enzymes in mammalian evolution that has been conserved throughout evolution. But where they're found within cells depends on the animal's diet. So in carnivores, these enzymes are found exclusively in the mitochondria, where they are used for gluconeogenesis. Well, why is that? Because carnivores don't eat a carbohydrate. So any carbohydrate they have, they've got to make. And their gluconeogenic enzymes are turned, gluconeogenesis means making new glucose, are turned on 100% of the time, all day, every day. If you are a plant eater, you're eating plenty of starch and glucose, so you don't need to have full-time gluconeogenesis going on. But what you do need is you need the ability to detoxify plant alkaloids, because plants don't want to be eaten, and they load up their tissues with all of these compounds like caffeine and some other more sinister ones that when animals eat them can either make them sick or kill them. So if you are dependent on plants, you have to have the ability to detoxify these compounds. That's why you can't feed your pets like aspirin and other medicines that, or you can't give cats onions because it'll cause hemolytic anemia and things like that. They can't handle those compounds. And so in strict herbivores, these enzyme systems are found exclusively in cellular organelles called lysosomes. In by design omnivores like bears and raccoons that are designed to eat both plant and animal foods, you find, okay, I get it, half in the mitochondria, half in the lysosomes. Where are they found in humans? Exclusively in the lysosomes, as they are in all strict herbivores.
Mic drop.